Hi everyone, it's a great pleasure to be here and thank you for coming to my talk, and I hope you will enjoy it. And I will talk about intelligent document processing. So I would like to start quickly giving you a general context on what we are exactly doing. So for the last few years, there has been a flood of new technologies for automating business processes in enterprises. And this is definitely one of the clearly visible one of the clearly visible trend is intelligent automation, which basically combines robotic process automation with machine learning capabilities. And just to name a few technologies, we have technologies like chatbots or voice bots. We have recommendation or personalization for e-commerce. We have tools for forecasting and real-time optimization, for example, for supply chain management. And also we have intelligent document processing, which I'm gonna talk about. Yeah, so in a nutshell, intelligent document processing aims to take an unstructured data like editable documents, scans, pictures, etc., and transfer them into a structured output that can be further used to make some decision, execute some actions, or just to store it. And at Alphamoon, we are developing a generic platform that can be effectively set up to handle almost any text or document processing problem that fits in this schema. And during this talk, I would like to share with you a few sneak peeks on what we are doing and show you just some pieces of technology that we are using, but without going much into details. So I will cover three different groups of problems that we are dealing with. And the first one is content capture. So the goal here is to transform a document into a fully digital representation. And it is almost entirely based on computer vision methods to solve problems like content segmentation, optical character recognition, table recognition or handwriting recognition, and a few more. The next group of problems is content understanding, where we mostly use NLP techniques to solve problems like document or intent classification, named entity recognition, or semantic search. And the last and probably the most challenging one is system trustworthiness. So the idea here is how basically we should develop a system that we can trust. So if we, for example, have observations that are beyond the regime of the training data. And if you had a chance to listen to a talk by Professor Marta Kwiatkowska yesterday, this problem is closely related to what she was presenting. Yes, so moving to content capture. So I'd like to start with a sneak peek of our own OCR. So maybe an interesting story I would like to start with is why we created our own OCR. So when working on real data from our customers, we were testing various OCRs, and our observation was that when you deal with documents that are good quality, it doesn't really matter which OCR you are using because they all work reasonably well. However, things are getting much more challenging and much more complicated where the quality of documents is low. And we wanted to have the ability to fine-tune the OCR on various types of documents. So we created a OCR, which is basically a combination of two methods. One is used for word detection, and the other one is used for word transcription. Probably you can all imagine that both of them are based on deep learning. And what you can see in the slide is just a comparison of what you can see on the left is the result of Tesseract. Tesseract is, I think, the most popular open source OCR. What you can see in the middle is one of, let's say, top 3 most popular commercial OCRs. And on the right, you can see our method. And correctly recognized words are marked in green. Orange indicates the word transcription error, and red shows that the words that weren't even detected. Here is another example of the results of different OCRs. And the next sneak peek I would like to show you is table structure recognition. And this is especially useful when you need to interpret tabular data, since the context for each piece of information in the table would be different than in the raw text. And the problem is especially challenging when you have to deal with visually complicated tables with missing lines, nested cells, etc. And to solve the problem, we developed a method that builds a relational graph for text fragments, and then we are using graph neural network to determine neighborhood class between each two fragments. And what you can see on the left is an example of table and the corresponding relation graph. And on the right, you can see the result of so the reconstructed table. Here are another 2 examples of the relational graph. And you can see the results of the edge classifications. So where green indicates neighboring rows, red are neighboring columns, and blue indicates whether 2 pieces of information lie in the same cell. Yeah, and here is another piece of the system, a method for identifying the document structure. So we aim here at detecting different objects in the document, like text, paragraphs, tables, handwriting, stamps, and a few more. Yeah, so now let's move to the second part, so to content understanding. So the core of our system that we are using here is based on a multimodal deep neural network, and which processes the entire document. And the idea is that it combines 3 different modalities, so textual, positional, and visual. And the idea is that for each token in the document, we add the information of its position and size, and also its visual appearance. And we use a large and pre-trained version of this model to solve both document classification problem and named entity recognition, so which we are using for information extraction from documents. Yes, and here is a screenshot from our app where the model was fine-tuned to extract data from invoices. What you can see on the left is a document with highlighted entities that were found in it. And on the right, there is a list of entities and their corresponding values. And maybe to show you a bit more, what are the capabilities of such models. So here are some details on the experiment setup. So the model was fine-tuned on about 1,000 invoices, and we were using 26 different entities, and it achieved 0.96 macro F-score on the test set. And you can see the detailed F-score distribution in the slide. So what is probably the most interesting here is that the model has the ability to generalize across different document layouts and different document templates. And even a partial ability to generalize across different languages because of using information from different modalities. And here is an example why having a robust OCR is an important part of the system. So in particular, text detection is sometimes challenging for different OCRs, especially when you have non-uniform backgrounds. And you can see that even if a document is, for example, crumpled or has had coffee split on it, our method for entity extraction works fine. Yes. And now let's move to the last part of my talk, so system trustworthiness. And to explain the idea, I would like to start from something that we call accuracy automation trade-off. So let's imagine that we would like to deploy the system for example, for reading invoices and extend it with a mechanism, for example, for automated payment. And in such a case, you have to be absolutely certain that the system achieves at least the human level performance, which of course might be intractable in many cases due to, for example, lacking training data or just because of technical limitations of deep learning methods that you are using. So what you can do is to, let's say, double check everything, but then you have not much gain from automation. And of course, on the other hand, you can process everything automatically, but you don't have accuracy guarantees then. So the question is, can we do something in between? So can we pass just some portion of information to a human for a verification to gain from both? So to have guaranteed accuracy and also pretty high automation. So the very basic idea is just to set that confidence level for your classification model, let's say, high enough to ensure that your model's accuracy is above the desired threshold, for instance, 99%. And what you can see here are the results of the experiment that shows that it is not necessarily a good idea. And the problem is that deep learning is in general bad at estimating uncertainty, especially in the regions that are not covered with training examples. And what you can see in the plot on the left is that when you're using approach, when you're just using the approach when you're setting the confidence level, the automation level that you can achieve is about 35%. And we are working on different approaches where the level of automation you can achieve is over 2 times higher in this example. So this is very important from business perspective, since the level of automation is, of course, proportional to the ROI you get at the end of the day. So yeah, and that's it. So thank you very much for listening. And one final announcement. So we are hiring at Alphamoon. So if you're interested in what we are doing, feel free to send your CV to recruitment@alphamoon.ai. Thank you.